Hi, my name is Walker Gallman. This is my lab report video for Lab 1 Charged Tapes for Physics 2212, which focuses on observing interactions between electrically charged pieces of tape and determining how much excess charge accumulates on each piece. The purpose of this lab is to observe the interactions between charged pieces of tape and to determine the amount of excess charges on the tape. The materials required for this lab include clear tape, a ruler, a flat surface, and elevated objects with flat surfaces to support the tape. Additionally, GlowScript was used to create a computational model to simulate the tape and interacting forces. The main results from the lab include that the charge on each tape was 1.074 times 10 to the negative 8th coulombs, and the number of electrons lost was 6.704 times 10 to the 10th electrons. Three fundamental physics principles were used throughout this lab. They include Newton's second law. This principle states that the net force on a system is equal to the change in momentum over the change in time. The gravitational force. This equation is used to find the gravitational force between two objects, and in this application is the force between a piece of tape and the Earth. And then additionally, Coulomb's law is used, which describes the force of attraction or repulsion between electrically charged objects. Coulomb's law is the principle that is used to find the electric force between two charged particles with charges q1 and q2, and is the formula 1 over 4 pi epsilon naught times q1 times q2 over r squared times the r hat vector. The initial conditions of the experiment are as follows. The tape pieces had a mass of 2 times 10 to the negative 4th kilograms, a distance of 0.023 meters apart, a tape length of 0.2 meters, a width of 0.01905 meters or 3/4 of an inch wide. The total tape area on each piece was 0.00381 square meters. The area of an atom being 1 times 10 to the negative 20th square meters, and the number of atoms on each piece of tape being roughly 3.81 times 10 to the 17th atoms. The system being observed in this experiment is tape B, with the surroundings being tape A, Earth, and all other external factors other than air resistance, as it is ignored in this experiment. The goal is to calculate the number of excess electrons removed from the positively charged tape, and here's how. First, you find the gravitational force, and it's found by applying the gravitational force equation, with the resulting magnitude being 1.962 times 10 to the negative 3rd newtons. Second, you find the electric force, which is equal in magnitude to the gravitational force, since the tape is overcoming the force of gravity. Step 3, using the electric force equation, I determined the charge on the tape to be 1.074 times 10 to the negative 8th coulombs. And finally, to find the number of electrons lost, you divide the charge by the absolute value of the electron's charge, and it yielded approximately 6.704 times 10 to the negative 10th electrons lost. A GlowScript simulation replicated the experimental process, accurately modeling the charge and electron loss. Important equations and formulas used in this model were outlined in the fundamental principles section. The model outputted the values for the force of gravity on tape B, the charge on the pieces of the tape, the number of electrons lost on one piece of tape, the number of atoms in one piece of tape per electron lost, and the electric field at tape B resulting from tape A, as well as the electric force on tape B. Assumptions included in this experiment are as follows. Air resistance is ignored and is considered negligible, as well as friction. The tape was treated as a point charge, and additionally, it is considered a uniform charge distribution throughout the tape. While simplifying the model, these assumptions introduced errors. For instance, charge distribution on the tape is not perfectly uniform, and handling the tape causes charge loss. Now for the discussion section. For the question, what if the charges of protons and electrons were switched? The effect is that nothing would change. All observations made in the lab would stay the same, as the now negatively charged tape would still repel each other. And for the second question, why is it important to minimize handling of tape? The charged tape can begin to neutralize when coming in contact with hands or other objects as they're trying to regain the lost electrons.